All right, hi everyone. So today's asynchronous work and then classwork will be about a question on the benchmark that a lot of us struggled on. So the first thing that I want to talk about is the law of conservation of energy. Most of you knew this definition by heart and did really well on that part, but we still have a little bit of work to do on applying what that means. So the law of conservation of energy says that energy cannot be created or destroyed. However, energy can be transformed between different types. So that means that when energy looks like it is being lost, it is actually just changing into a different type. So this could be kinetic to potential, potential to electric, chemical to kinetic. Any type can change to a different type. And the common example that we have been using, of course, is this roller coaster problem. And so I want to talk through each part of this because we got a little bit confused on that last open response question on the benchmark. All right, so the first part here, this is a roller coaster going up a hill. In order for a roller coaster to go up a hill against gravity, there's some electricity involved. So right here we see electric energy being transformed into kinetic energy so that the roller coaster can move up the hill. And that means that there is also an increase in potential energy. So the potential energy is increasing as we move up the hill. The kinetic energy is staying about the same because the electric energy that's going in is going in to maintain a specific speed here. All right, so at the top of the hill, almost all of you got that was the most potential energy that the roller coaster has throughout the whole ride, because this is the highest hill, so it's the highest potential energy. Then and there's still a little bit of kinetic energy at this point, right? The roller coaster is moving just a little bit. And then there's generally, so I've only been on like 2 roller coasters because I actually really hate heights, but I think that at this point there is kind of a click and you can feel the roller coaster disengage from that electric power. And it lets go and it starts speeding down the hill here. And that's a point where the potential energy is being transformed into kinetic energy. Then when we're at the bottom of the hill, there's still some potential energy, right? Because this isn't at ground level yet. So there's still a little bit of potential energy, but most of the energy in this system is now kinetic energy, and the roller coaster is moving super fast. It's able to make it up this hill, probably without electric help because it's a smaller hill. And again, it's transformed back into potential energy. So there's a lot of potential energy here, a little bit of kinetic, and then it goes back down the hill. It's losing a ton of potential energy here, gaining a lot of kinetic. Now the question here is that as it starts to flatten out, let's imagine that this is the end of the roller coaster a little bit past here. So it's going to be flat for a while as the roller coaster starts to slow down. So at that point, there's no more potential energy left because the roller coaster is at the very bottom. So there's no potential energy, but also the roller coaster is slowing down. So that means that we are losing kinetic energy throughout this flat part. So there's no potential energy and there's less and less kinetic energy. So the question is, what happened to the rest of the energy? We know it can't be created or destroyed. So why is there some missing energy here? The answer is that it is transformed into some other type of energy. So if you've been on a roller coaster before, you've probably heard that it's pretty loud. As it is slowing down, it's losing some energy to sound, which is a type of energy. It is transforming some of that kinetic energy also into heat because of the friction on the tracks. So if you were to touch the tracks right after a roller coaster passed, it would feel really hot. And that's some thermal energy that has been transformed from kinetic energy. And then maybe there's some light. I don't know if there are ever like sparks happening on roller coasters, but if there's a little bit of sparking, then that's some light energy as well. All right, so just to summarize that, as the roller coaster rolls down a hill and onto a flat surface, it loses kinetic energy and doesn't get any more potential energy. That means that kinetic energy must have been transformed into other types: sound, heat, maybe a little bit of light, etc. And let's keep in mind that this was also happening throughout the rest of the ride. It's not like the rest of the ride was silent or like no heat on the tracks, right? The whole time some of the kinetic energy is being transformed into sound and heat. But we notice it more at the end because it's also not gaining any potential energy. All right, so let's run through just a couple other examples of the law of conservation of energy, and then you will do the Google form. All right, so first one, when you drop a book from high up, potential energy is transformed into blank, but eventually that energy is also lost because it is transformed into blank. So you can do this with any object, right? If I were to drop this pen, there's potential energy here, there's no kinetic energy. Then if I were to drop it, it transforms into kinetic energy because it's falling. And then at the very end, it doesn't have any kinetic energy anymore. It's now just sitting on my floor. So what happened to that energy? You might have heard a little bit of a sound. The kinetic energy transforms into sound energy and probably just a tiny bit of heat energy also. All right, we have a baby penguin here. This baby penguin, like all living things, has a lot of chemical energy stored in its cells. So the baby penguin is turning chemical energy in its body into blank and blank. So all mammals are constantly turning chemical energy into heat in our bodies. And then also generally a lot of kinetic energy. So it's flapping its wings for unknown reasons. It might not have learned that it doesn't know how to fly yet, so it's really trying that. And it's using a ton of chemical energy to flap its wings and also to make some heat. All right, and one more. Wind turbines work because the kinetic energy of the wind is transformed into kinetic energy of the wind turbine blades. So that's just kinetic to kinetic. And then that energy is transformed into electric energy or electricity. All right, so that's it for the law of conservation of energy review. We'll do some stuff on this in class. And then I wanted to touch on just one other thing that a lot of people made a mistake on, and I want to make sure it's clear. When the roller coaster gets to point A, it's moving pretty slowly. When it starts to go down the hill, it starts moving quickly, and the further it goes down the hill, the faster it's moving. So the very fastest point on this roller coaster is at the bottom of the hill, right before it flattens out. So right here. So anytime there's these roller coaster questions come up a lot, especially in physics, the highest point of kinetic energy is down at the bottom of the hill because that's where it's moving the fastest. It's moving pretty fast here in the middle, but it's definitely moving faster at the bottom. So just keep that in mind. All right, go ahead to the Google form, complete that, and submit it. I will see you in class.